Okay, today we're going to be looking at, from our Year 13 pure, what is called composite functions, when we're looking at how functions work and combine them in several different ways. So, for example, if I got two different functions, g and h, g is such that x goes to x minus 3, h such that x goes to x squared. In words, what is g doing? It's just subtracting 3. What is h doing? It's squaring it. Now, depending on which way around we do things, we get different functions. So, for example, if I take our x, apply g to it first, i.e. subtract 3 to get x minus 3, and then square it to get x minus 3 all squared, I'm doing g first, then h. Now, my overall function I get, f, x goes to x minus 3 all squared, can be written as f of x equals h g of x. Notice the order is the opposite way around to what's being done. You've got to think about going from x and working outwards. What letter is closest to x, that's what gets done first. So it's actually sometimes more useful to think of it as being h of g of x. So I'll do g first, and then whatever the function that is, I stick that into where h is, like this. Okay? So let's have a look at a couple and how they're applied. Fx is such that x goes to 3x plus 1, so times 3 and add 1, and g of x is such that x goes to x squared. Now, if I want to work out the value of g of f of 2, what I do, I stick 2 into f first, and then stick that into g. So when I stick 2 into f, times by 3, and add 1, 6 add 1 is 7, I get g of 7, and 7 squared is 49. If I did it the other way around, I might occasionally get the same value, but not all the time. So f of g of 2 means I stick 2 into g first, so I square it to get 4, and then stick 4 into f. So times by 3, 12, and add 1, 13. Part B asked me what values are the same if I do f of g or g of f. Now, what I can do in this case is simply work out the function. So f of g of x is f 3x plus 1 of x squared, so it's 3x squared plus 1, and g of f is squaring whatever f is, which is 3x plus 1 all squared. Bit tight for space, but see what I can do. 9x squared plus 6x plus 1. The plus 1's cancel out. When I move the 3x squared across, I get 6x squared plus 6x equals 0. It's going to factorise and leave with x equals 0 or minus 1. X equals 0 or minus 1 as my solutions there. So it doesn't matter which way around I put them in. If I stick x is 0 in, I get 1, and x is 0 in that, I get 1. If I stick x is minus 1 in, I get 3 add 1, which is 4, and I get minus 2 all squared, which is also 4 there. Those are the only two values that are the same. Now, not only can I do composite functions of 2 different functions, I can do potentially of 3. And so I've got 3 different functions here. F of x is x add 5, in words, add 5. G of x is x squared, squaring. H of x is 3x times by 3. So if I want to work out f of g of x, then I do g first, x squared, and stick that into f. So it's, as it were, it was f of x squared. So I stick x squared where the x appears in f. If I want to do the other way around, g of f of x, where I'm sticking and doing g of x plus 5. So I'm sticking that where the x appears in that. So it's x plus 5. What is g doing? It's squaring, so it's squaring the x plus 5. F of h of g. Now I've got to be careful. If I'd already had 2 of these next to each other previously, I could have used it, but I haven't, so I've got to do it step by step. So I'm doing f of h, or whatever g is, which is x squared. I should have put x there. So and then stick x squared into h to get 3x squared, and that's h of g. So I've squared it first, then times by 3, and I've got to put that now into f to get 3x squared over 5. Other way around, I've got to do h first, so it's 3x, and I can hopefully here I might be able to get away with this one. We'll see. What I should get is, I've already got f of x in there is x plus 5 all squared. I could put 3x into that straight away, but I'll do it bit by bit anyway in this case. So I'm going to put 3x into f to get 3x add 5. And then I've got to put that into g, so I'm squaring it. And as I said, I've got 3x add 5 all squared. Now, I can do the same function repeatedly. So in this case, it's a bit weird doing it this way. F of x, when it's x plus 5, isn't just 3 lots of that. There's aspects where I'm times by 3, you'll see in a moment. It means I'm doing x plus 5 into f again. I've got x plus 5 into f, well I'm doing x plus 5 plus 5 to get x plus 10 into f, and guess what? I get x plus 15. Notice it's not 3x, it's 1x, because I'm just replacing where x was with whatever appears in the brackets there. Your typical A-level question though, here we go, combines all the things we looked at in the last couple of lessons. Here's two functions. F of x is 63 over 4x minus 1, where x lies between 1 and 16, and g of x is x squared, where x lies between minus 4 and 1. So I need the range of f. So it's what we were doing last time round. It's probably not a bad idea to do a little sketch here. So I'm thinking that it would have x equals a quarter will be an asymptote, and it would tend down towards there, and so in particular I'm after this particular part of the curve which goes from x is 1 to x is 16. So I need the y values there and the y value there. So stick x is 1 into this, 63 over 3, 21, and stick x is 16 in, 63 over 63, and 1. So the y values go from 21 to 1. I can say that fx then lies between 1 and 21. That's my range. Work out the composite function f of g of x. Well, it's just f of x squared, so we'll replace x with x squared to get 63 over 4x squared minus 1. And lastly, solve this function, 63 over 4x squared minus 1 is equal to 1, cross multiply. Move across, divide by 4, x squared equals 64 over 4 is 16, so x equals, got to be careful here, 4 or minus 4. Now, for it to satisfy this, we're looking at this part of the curve, where x lies between 1 and 16, it can't be minus 4, so that's my only solution, x is equal to 4.